Welcome to the another session of engineering chemistry. Last class we have discussed about the fundamentals or basics of the electrochemistry. Now we will again continuation with the topic. I am Dr. B. Shekhar, working as an associate professor in Marri Laxman Reddy Institute of Technology and Management. In last class we are discussed about the fundamentals and basics of the electrochemistry. To easily understand the electrochemistry, along with that also we are seen about the electrochemical series, and with the help of electrochemical series also we are discuss about a electrochemical cell. To explain that electrochemical cell, we took as a Daniel cell or galvanic cell is one example. Up to this we are seen in our last class. Today we will see about the one more important topics we have in our electrochemistry, that is the electrodes. So especially here we have the three type of the electrode. One is calomel electrode, one is quin hydrogen electrode, and another one is glass electrode. Actually, what is mean by the electrode? First we will see the definition for the electrode. A material which possesses electrons or conductivity with them we called as a electrodes. They may be rods or the metal plates. It is a simple definition for the electrode. Now we will see about the one of the important electrode, that is a calomel electrode. It is a diagram, simple diagram to understand about the calomel electrode. Now we will see about the construction of the calomel electrode. This is a secondary reference electrode for measuring the single electrode potential. The calomel we are using to determine or to find out the potential of a single electrode. We are using the calomel electrode. The calomel electrode consists of a glass tube having two sides tubes. Here you can see it is a look like a glass electrode, and these are the two inlets or outlets we have in this. A small quantity of pure mercury is placed at the bottom of the vessel and is covered with a paste of mercury. You can see here it is filled with this calomel electrode is filled with saturated KCl solution, and below the KCl solution at the bottom it is this black color, it is a mercury. We are placed mercury, and above this mercury we are also placing the paste of the mercurous chloride and mercury. Mercurous chloride and mercury, and here KCl solution of known concentration is filled through the side tube, which helps to make a concentration through a salt bridge with the other electrode. Which electrode potential we need to find, that is we are connected with that. Which electrode has to be determined? Yes, which electrode potential we want to determine, that is we are connecting with the calomel. The potential of calomel electrodes depend on the concentration of KCl solution. Which KCl solution we are using here, it is definitely affects the potential of the electrodes. A platinum wire is sealed into a glass tube as shown in the figure, which is in contact with mercury, and the electrode is shown as mercury and mercurous chloride and KCl. Here it is our platinum wire. It is immersed or it is placed middle of the glass tube, and it is connected to the alternatively which electrode potential we need to find out, we are attaching to that. It is about the simple calomel electrode. The calomel electrode we are using to find out the potential of the other electrode, And here second point, mainly we are using the saturated KCl solution. And why this electrode we are calling as a calamole electrode? This the mercurous chloride we called as a calamole. So here we are using the mercurous chloride. So due to that mercurous chloride also we are calling as a calamole. So because of that reason we called as a calamole electrode. This is about the calamole electrode. And what are the uses or merits and demerits of the calamole electrode? Especially why we are using here to find out the potential. So here we will see first one, potential of electrodes remain constant with the temperature. It is not affected with the temperature. That is one of the merit. And easily doing the oxidation and reduction reactions. Both oxidation and reduction reactions are easily doing, and it be carried easily. You can handle it is very easily. Construction is simple, easy. Yes, we need to attach with other electrodes or other calum electrodes. That is very easy, and it is a practical electrode. Already we are seen it is a secondary reference electrode. We are already spoke that one here. And now we will see about some of the demerits. Every time here, what is the disadvantage? We want to change the KCl every experiment. Along with every experiment, we need to change the KCl solution. So here solubility of KCl is sensitive. Solubility of KCl is sensitive, and the mercury is toxic and it is harmful to the human beings. So these are the two demerits or disadvantages we have with the calamole electrode. And coming to the second type of the electrode, it is a glass electrode. The glass electrode is invented in the 1909. The Fitzhaber and Judd Clemency Woods, they are introduced about this glass electrode. In 1909, these two scientists, they are introduced this glass electrode. The glass electrode consists of a tin-walled glass tube. It is a glass tube. It is very thin and sensitive glass tube we have. The glass must be corning the 0.15 and containing 72% of silicon dioxide and 22% of sodium oxide Na2 and 6% of CaO calcium oxide. These are we are maintaining to construct that glass tube. The glass in bulb act as membrane. This below it is a acting as a membrane, and it has a relatively low melting point and high electric conductivity. It has a very sensitive and it has a high conductivity. The bulb contains a solution of constant pH. It contains the constant pH. This solution is usually 0.1 molarity of HCl. It is a 0.1 molarity of HCl we are using in to fill this solution. Here this is we are filling with that solution. A silver chloride electrode is immersed partially into the solution. Then the electrode can be written as silver chloride and 0.1 HCl hydrochloric acid and glass membrane. It is representation of the electrode. It is a representation of the glass electrode. Here it is we are immersed in the middle of this electrode. The middle of the electrode, it is, I think you are visible in this one. It is we are immersed in that solution. Alternatively, a platinum wire is inserted in 0.05 molarity potassium hydrogen phosphate phthalate buffer to maintain the buffer condition. Here it is also maintaining here. When two solutions of different pH values are separated by glass membrane, a potential is established across the membrane. When this glass electrode is connected with other electrodes, the due to the potential difference, it is varies, and that potential is establishing across the membrane, and it is we are finding with the help of the pH meter or any other meters. To find out the potential value with the help of glass electrode, simply we are using this formula. E means nothing but a cell. The E is equal to E naught plus 0.0591 into pH. E means nothing but the cell. It is a cell. E naught means it is a standard cell. Standard cell plus 0.0591. Its value came from the Nernst equation, and into pH we are finding this glass electrode connected with the pH meter. So here we are using pH. This is about the glass electrode. It is a simple diagram to understand about the glass electrode. And these are again some of the merits and demerits we have with the glass electrode. It can be used even in strong oxidizing solutions. We can use with the help of the strong oxidizing agents also. It can be used in colored, turbidity and colloidal solutions. If the test solution, they may be in the form of turbidity, or if they may have in color also, we are not bothering about that. It is works in that. Small quantity of solutions are sufficient to touch with this sensitive part pH bulb. The solution is that much of enough or sufficient to test the potential. An accuracy of 0.01 pH can be maintained. Here we are maintaining the accuracy, and it can be used whether required like chemical labs, industries and biological labs also. The pH meter, we have variety of uses, so all kind of industries like pharma industries and biological industries and chemical industries also we are using. These are some of the merits, uses we have with the glass electrode. And what are the disadvantages or demerits with the glass electrode? Here, very high resistance of glass membrane make it not to measure EMF with potentiometer, but with an electrometer or vacuum tube circuit. So due to the high sensitivity of this glass, it is difficult to handle or maintain when connected with potentiometer. In solutions of pH greater than 9 containing sodium ions, the pH values are innocuous. Means we are getting some error values when the pH solutions contain 9 and above. These are some of the demerits we have with the glass electrode. In today's class, last class, we will discuss again. Last class we are seeing about this galvanic cell or Daniel cell, and today we are started about the type of the electrodes. In the so many different type of the electrodes we have, we are seeing about the one is calomel electrode, another one is glass electrode, along with their construction, means the simple diagram to understand the calomel electrode and the glass electrode, and their merits and demerits we are discussed here. And these are some of the reference books for more further information. If you want, kindly you can look it into this. This is today's session. Next class we will continue in next session. Thank you.